Hi, Olivia. Thank you for your question. I thought it would be quicker if I just made a little video to respond to you. So, thanks for trying to match up the things that you see on the equation sheet with the things from our class. That's an effective way to study. And the equation sheet is always a little different for the AP exam because they'll include equations that they plan to use. So, there could be a few more or a few less than were there last year, for example. But when we take a look at this top section, pardon me, hopefully you recognize KC, right? And KP. Ka, B, and W, and the remainder of these equations are all in my acid notes, the notes that I posted, and there's a video there. So I would say to study for these, watch the acid notes video that I made. It's only 20 minutes long and it goes with the notes that I made for class, and the practice worksheets. Give those a try because they cover the ones that you don't recognize. A is for acids, just like C is for concentration and P is for pressure. B is for bases and W is for water because, of course, when you mix an acid and a base, you make water. And then, I'm sure when you think about acids and bases, you think about pH, right? The pH scale. Well, there's also something called pOH, so we have equations for both. And putting things on the P scale is something that you can not only do with the hydrogen concentration, but you can also do it with the equilibrium constants for acids. So I cover those in the notes. What about this section? Let's see, we did not get around to doing this lab, and I was going to try to cover it in class last time, but hopefully you do recognize this equation, and these three look really similar. So sometimes when I know I don't have time to do all three things, I'll try to do one and hope that your experience with that one equation will give you a little confidence when you see an equation that instead of using H, maybe has S or has G, but you're given those numbers and you can just plug them right in. So let me remind you that this was a unit 5, I'm going to say 5 topic, but anyway, I think this is your unit 5 quiz. It's on bonding, and we have that same equation right here. Oh, I'm sorry, it's the second equation here. Now, delta H is enthalpy. Remember, enthalpy is total heat. Whereas delta S is entropy, which is randomness, and delta G is free energy. So these are all really similar things, but let's see how delta H works. I'm not sure that we're going to have time to go to delta G or delta S in class. And so for those few things that we don't have time for literally, I would say, take a look at the AP daily videos in the AP Classroom app. But let's take a look at the ones we did do from class on your Unit 5 quiz. So we have one of these problems here where it says use the bond energy values, and notice these values are kilojoules per mole. These are the delta H values. And calculate the enthalpy. Remember, delta H, it means change in enthalpy, right? Delta means change in, H stands for enthalpy, which means total heat content. So, we use these values, and we're going to use that equation. So what you really need to know about these is that often the delta H values will be given to you for an equation, and you'll just either plug them into the equation, and sometimes you'll have to realize that they are per mole. So sometimes it's as simple as plugging it in, but if you've got more than one mole of something or more than one group of molecules, then there may need to be a multiplier. So just as a quick reminder here, we've got a CH value with 413. We needed to count these 4 bonds and say that there's 4 of them times the 413, and these units again are kilojoules per mole. If we went ahead and followed the equation said take the sum of all these reactants here and add them together and then subtract the sum of all these products here. So that's what I'm going to be plugging in. So what about for O2? So O has a double bond, and the fact that there's 2 of them, Remember, that's something you have to pay attention to because kilojoules per mole, if there's 2 moles, that means we have to double it. So that's just something we want to look out for. Let's look for the O double bond O, 495. And again, there's 2 of those that need to be broken in order to do that. 1, 2 bonds here, they're both CO double bonds, so that's 745. And yep, there were 2 of those. And this one's interesting because you have a OH bond twice, but then you see that 2 in front. So can you mentally kind of copy that molecule and paste it? So actually, you're going to have a OH bond 4 times. Okay, so that's 4 times whatever the enthalpy change for forming an OH bond is. 467. Remember, this is the question that we decided to kind of take off the semester exam at the last minute. The other class, the teacher felt that they weren't ready for it. So, but I'm so glad you pointed it out. Anyway, so delta H, according to the equation, is all of this. So you'll just sum those things together that are on the reactant side, sum those things together that are on the product side, and subtract the 2.